Hello everyone, I am Akash Shah from 4th semester Computer Science and Engineering Department of Barakville Engineering College. So today I am here with my friends to give a presentation on backpropagation using neural network, which is a topic of machine learning presentation. So starting with the table of content. So first is the neural network, then forward propagation, loss function, backpropagation and conclusion. So I will continue with the part of neural network. So a neural network is a model inspired by the human brain. So it consists of the neurons connected by weights. So the basic neural network contains input layer, hidden layer and output layer. So the input layer takes the input data or receives the input data. Then the hidden layer performs all the computations and features of extractions. Output layer produces the final result. So the key idea of the neural network is that it learns the pattern by adjusting weights. So there is a line saying that each neuron receives inputs, processes them, passes output forward. So going to the next slide, neural networks are especially powerful in solving complex problems such as image classification, speech recognition, natural language processing, handwritten digit recognition. So there is a diagram or structure of neural network. It shows that how a neural network is processed, like starting with the input nodes, then comes up the hidden nodes, and at last there is the output node. So next, I will request my friend to come and continue the presentation.
Thank you, Akash. Now let's move forward to the forward propagation. So forward propagation is one of the most important process in neural network. It is the process through which input data travels from input layer to output layer of neural network to generate a prediction. Like for example here, this is the input layer. This is both of them are input layer, and this is the output layer. So here they get multiplied with their weights that is given, and then we get the sum, and we add the sum with the bias. So like here the formula is given, summation equals to x1 w1 plus x2 w2 plus b. So this is how the neural network actually works in forward propagation. So the main objective of forward propagation is to determine the output of the neural network based on the given input and current value of the weights and biases, as I explained to you right now. So the steps are: input features are fed into the network, compute weighted sum plus bias, apply activation function, then pass the output to the next layer, get final prediction. So for example, let me take an example. For example, x1 is equals to 2, x2 equals to let's assume 3, then w1 equals to w1 equals to zero point 0.5, and w2 equals to 0.8. So let's take the bias. Let us assume the bias is 1. So b is equals to 1. So when we will apply the formula, the formula is x1 w1 plus x2 w2 plus b. So 2 into zero point 0.5 plus 3 into zero point 0.8 plus 1. So the final answer that we will get is around, I guess, 4.4. And since this 4.4 is greater than 1, so our output will be 1. So this is how the forward propagation works. Thank you. Now let's go forward to Vijit. Vijit will explain you the loss function.
So thank you, Vinith. I am Vijit Acharji, and I am going to present the topic about the loss function. So loss function is the most important topic in the neural network. It basically describes that your model value and your original value is how different they are, how far from they are. It actually considered as an error. So errors can be calculated by this function. This is the MSE value, and MSE value describes that your model value is generating a value which is far different from the original value. Let's suppose your model is generating the value which is 0.6, but your original value is considered that you have predicted before the model testing is 1. So there is a 0.4 error. So if it is less, then it's okay, but if it is more, then we can consider it is a high error. It's not good for us. So if the error is much high, then it is a large loss. If it error is small, then it is a small loss. The actual value that we get from the model is considered as the model prediction y cap, and the actual value that we have predicted before the machine learning model prediction is y. We can compute that and we can get the value of the loss function. Now I will explain why loss function is important. Loss function is important because it gives the model learning of the information about how a model is working properly, how a model is not working, how what is the difference, what is the difference between actual model and what is the difference between the model, how it describe uh, the principles and all the functions. It gives the idea about the problems in the model. Every problem has different loss function. For every model, input is different and loss function is also different. So it directly affects the training performance. If the loss function value is much higher, then it means their training error is much high. So it can be recorrected by backpropagation. So now, connecting to the backpropagation, loss function is actually the starting point of the backpropagation, because backpropagation is nothing but the forward propagation, which is corrected by the backward propagation, and the loss function gives the value y and how much value and weight we should change during the backward propagation. And the next backward propagation section will be discussed by my next.
Good morning, everyone. My name is Gauri Shankar Acharji, and I'm going to continue with the backpropagation part. So, from the forward propagation, we already discussed how to calculate the y hat, and after calculating the y hat, we will have to find out the loss function, that is y minus y hat square. If the loss function is a minimum, then we don't have to apply for backward propagation. But in most of the cases, the loss function is not minimum, so we will use the backward propagation. Here we in backward propagation we update the weight after calculating dl by d z2 and dl by d z1 in order to reduce the error. So here dl by dz2 is equal to dl by dy hat into dy hat by dz2, where y hat is the activation function of z2. The derivation of activation function will be activation function into 1 minus activation function of z2. Now we will calculate the, dl by dy hat, where l is the loss function y minus y hat square. So the derivation of it is 2 into y minus y hat. Now we will calculate this for each node, that is for dl by dz1 is equal to dl by dz2 into dz2 by da1 into da1 by dz2. Now we will put the values. If you want to calculate for weight as well, we can do that by for weight dl by dw2 is equal to dl by dz2 into dz2 by dw2. So this will be the formula for calculating the weight, for calculating in terms of weight. Now let us move on to a more complex model, more complex multi-layer model. So here dl by d from the previous model, we already know how to calculate dl by dz3 for the last node, that is dl by dz3 equal to dl by dy hat into dy hat by dz3. Similarly for dl by da1, we will follow the path and the weight in that particular path. So dl by dz3 into dz3 by da1 into da1 by dz1. Also for for the z2 node, we will calculate it by dz2 by da2 into dl by dz2 into dz2 by da3 into da2 by dz3. So these are the formulas for calculating in terms of more complex multi-layer network. So now let us move on to the PPT part of the presentation. Now I'm going to explain the machine learning. Now I'm going to explain the backpropagation part through my PPT. So let us move on to that. Thank you. So as we have already discussed the mathematics part, now I'm going to continue with the PPT part. So now we are going to discuss learning rate. So if the learning rate is more, the model does not properly learn all the complexities of a problem. So a safe spot for learning rate is said to be 0.01. So we'll use 0.01 as learning rate so that the model could learn the complexities of the problem properly. Now, in terms of weights and biases, for weights, if the weight increases error, we will decrease it, and if the weight decreases error, we will increase it. Gradient tell both the direction and magnitude of change. So, for example, if we take a graph. So the slope here, if we go towards the right hand side of this graph, the slope will decrease. So the error will also decrease. So as we go down this slope, the gradient is negative. So the error will definitely decrease. But when we are in this position and we decide where to go, if we go on the right hand side, then then the gradient will become positive and the error will surely increase. So this is why gradient tells us both direction and magnitude of change. Now we will go to the next slide, that is gradient descent. So we have already discussed what gradient is and what gradient descent is. If we go down the slope, then error will decrease, and if we go above, I mean in the right hand side of the slope, then error will increase. So we were so the concept of learning rate is also discussed. Now I would like to end this PPT here only. So thank you.